Hello everyone, and thank you for joining me. My name is Spencer Allingham, and I'm the Technical Director at Conducive for Europe, the Middle East, and Africa. And today I'd like to talk about the Velocity I/O reduction software that Conducive manufacture and why you might want to install it on your SQL servers to improve performance. Now, it doesn't just benefit SQL, but of course other databases as well that are running in Windows and other application types too. But we'll mainly focus on what we can do for SQL Server today. And you'll see in the WebEx window, hopefully, a Q&A box. And if you have any questions as we're going through, please do feel free to use that Q&A box to present your questions, and I'll be more than happy to stay on after the presentation to answer as many of them as I can. Now, everybody who's attending today will receive a single license of the Velocity software that's yours to keep, and you can install it on one of your busiest servers and use it to improve performance and reduce storage I/O inefficiencies. But if you really want to make sure that you're getting the very best results from it, feel free to get in touch with me directly as an engineer, and I'll be more than happy to ensure that everything is configured for best results. And I'm also going to go through some helpful best practice tips for using Velocity with SQL later on in the presentation. So to illustrate why you might want to consider downloading and installing the Velocity software onto your SQL servers, I ran some lab tests using HammerDB to generate an online transaction processing type workload with and without Velocity installed. Firstly using SSD storage and then using spinning disk storage. And as you can see from the metrics on the screen recorded by HammerDB, on the SSD storage, there was about a 30% improvement in the number of SQL transactions that could be processed per minute. And this was backed up by the PerfMon or Performance Monitor metrics that showed about a 28% improvement in transactions per second. When running the tests again using spinning hard drive storage, there was around 100% improvement. Now, either way, this is great news for SQL DBAs who care about the performance of the databases underpinning their business-critical applications. Now, whether you're running SQL in a physical or virtualized environment, most SQL DBAs would welcome faster storage at a reasonable price. And Conducive's Velocity software is designed to provide exactly that, but using the storage hardware that you already own. It doesn't matter if you have direct attached disks, if you're running a tiered SAN, maybe have a tray of SSD storage, or if you're fortunate enough to have an all-flash array. That storage layer can be a limiting factor to your SQL database's productivity. And the Velocity software reduces the amount of storage I/O traffic that has to go out and be processed by the disk storage layer. And it streamlines or optimizes the data which does still have to go out to disk. So the net result is that SQL can get more transactions completed in the same amount of time, quite simply because on average it's not having to wait so much on the storage before being able to get on with its next transaction. And Velocity can be downloaded and installed without any disruption to live SQL servers. There are no SQL code changes required and no reboots. You just simply install it, and typically you'll start seeing results in just a few minutes. Now, before we take a more in-depth look at that, I'd like to briefly mention that last year, the Velocity software was awarded the Microsoft SQL Server I/O Reliability Certification, which is quite a mouthful. But basically, this means that whilst providing faster storage access, Velocity didn't adversely affect the required and recommended behaviors that an I/O subsystem must provide for SQL as defined by Microsoft themselves. Now, most SQL DBAs are familiar with why split pages are bad for performance. If you've got room and your update or insert doesn't require a split, Well, this is pretty fast because SQL is just updating one page and then writing it out to disk and to the transaction log. But if the updated or inserted row doesn't fit, SQL needs to allocate a new page, move about half of the rows to the new page, and then write both pages to disk and to the transaction log. And in addition, the pages and all the indexes that point to the data pages, well, they need to be updated too. So let's say that your table had one clustered index and 4 non-clustered indexes. That would mean at least 7 pages would need to be updated. You would have 1 for the clustered index structure, 4 for the non-clustered indexes, and 2 in the data pages in the clustered index. So this page split would result in a minimum of 7 times the I/O as an insert or update that didn't require a page split. Now, each I/O that takes place takes a measurable amount of time and resource to process. And the same is true when the Windows file system splits data as it writes out to the logical NTFS volume. And that can have significant performance ramifications too. And this is basically why DBAs format volumes to be used by SQL with a 64K cluster size, rather than using the default for NTFS of 4K. And it helps to avoid split I/O situations when writing to disk, and keeps performance-losing file fragmentation from building up so quickly. But it doesn't completely fix the problem though. As your NTFS file systems mature over time and files are created, extended, and deleted, the free space on the NTFS volume will become more and more fragmented into smaller and smaller free space extents, increasing those split I/O situations when writing data. Now, each time your write is split in this way, the data is being sent out to disk in a separate I/O packet. And like split pages in SQL, each I/O takes a measurable amount of time and resource to process. So in the real world, a gigabyte of storage I/O traffic that should be written in maybe 2,000 or 3,000 I/Os could now be taking 30,000 or 40,000 I/Os to complete. And we call the performance penalty that these split I/O situations cause the Windows I/O tax, as in a tax on your performance due to the split I/Os. Now, in a virtualized environment, this performance penalty can be amplified by something called the I/O blender effect. And what's happening here is that you have small, fractured I/O packets coming from the virtual machines. And as they pass through that hypervisor, the hypervisor basically mixes these I/O streams together, causing a randomization effect. So that then what comes out between the physical host hypervisor and the disk storage controller is really now a chaotic mess of small, fractured, and now very randomized I/O streams that by the time they hit that storage controller, they really couldn't be less storage friendly. And it means that the storage controller is only receiving data in very small packets at a time, so it now only has the opportunity to create very small stripes across its media, and that means many more storage level operations than if the data hadn't been split as it was being written all the way up at that NTFS layer. Velocity helps Windows avoid or prevent most of the excess, unnecessary, performance-losing split I/O traffic and replaces it with far fewer storage I/O packets, each one carrying a larger payload of data. This makes the movement of data between server and storage quite simply more efficient, much like avoiding page splits wherever possible, and allows the disk storage to store the data using far fewer storage level operations. And Velocity will also help create those nice large free space extents quietly and automatically in the background using only otherwise idle compute resources to make it easier for the Windows write driver to write into. So think for a moment of a busy freeway or motorway at rush hour. Imagine that you've got lots of cars sitting bumper to bumper with one person in each car, and none of them are getting anywhere very quickly. Now, imagine that each car on the motorway is a storage I/O packet, and each person in each car is your data. What Velocity is basically doing is taking all of the people out of the cars and placing them in buses or coaches and removing all of the little cars from the motorway and getting rid of all of that congestion so that now all the people or your data can now flow to their destination in a much more efficient manner. Um, that might be a bit long-winded, but I hope it makes sense as an analogy. um, but that's really only half of the story. Velocity also introduces a RAM caching technique into the Windows operating system that further reduces the read I/O traffic that the backend storage has to deal with. The performance benefits provided are in addition to SQL's own buffering and any caching natively provided by the Windows operating system. And basically, this is how we could get 30% more SQL transactions done in the same amount of time during that testing that I mentioned before. Quite simply, SQL could get more work done in the same amount of time because it wasn't having to wait so much on that disk storage layer before being able to get on with its next transaction. And also basically because RAM is faster than the media you have in your disk storage. Oh, and it absolutely works with both physical and virtualized SQL servers and in the cloud as well. So storage I/O reduction, optimization, and RAM caching represent a significant reduction in workload that has to be processed by the backend storage. And this is not only true of SQL Server's storage traffic, but other workload types too, as long as you're running them in Windows. So in this example, let's say that the first VM is hosting SQL, and the second VM is hosting the application that interfaces with SQL, and the other two VMs are hosting busy file servers. And they're all sharing that same backend storage. Let's say that's a SAN at the back end. You might have a situation where the traffic from the file servers are taxing the performance of SQL by keeping the storage layer busy. So SQL isn't necessarily the cause of the disk storage being low, but it would likely be affected by the increased disk I/O queue depths and latency that's being caused by the busy workloads on the file servers. So my recommendation would be to install the Velocity software on all Windows machines that are sharing the same backend storage. That way, from the point of view of the storage, quite simply, it's now doing the least amount of work, regardless of which VM is generating the most workload at any given time. Now, at this point, some of you will probably be thinking, yes, but SQL is already using most of the available memory in the machine. How can you possibly create a RAM cache? And it's true that if SQL is left uncapped, there typically wouldn't be enough RAM for conducive software to create a cache with. And we've intentionally designed our software so that it can't compete for system resources with anything else that's running in the machine. It's basically so that we can never be the cause of a memory starvation situation. Velocity would only use some of the free RAM that isn't being used by anything else, and it will dynamically size the cache, handing RAM back to Windows if other processes or applications need it. So for best results, you can easily cap the amount of RAM that SQL takes for its own form of caching or buffering. On busy database servers, if you can leave 16 gigabytes of RAM free, well, you'd have a Velocity cache size that would really be enough to make that machine's performance fly in most cases. And if you can't spare 16 gig, leave 8 gig. If you can't afford 8 gig, leave 4 gig free. Even that is enough to make a difference. If you go much smaller than that, though, then the cache size would really be a little bit too small, and any performance improvements that you would then get from the caching would be somewhat limited. But hopefully that gives you an idea of sizing. And you might also be thinking that, well, actually, SQL's buffering is good enough. So how does Velocity's caching complement this? And at a basic level, it's true, SQL's cache does do a pretty good job. And whilst that does have a positive impact on performance, Velocity's RAM caching is designed to eliminate the type of storage I/O traffic that tends to slow the storage down the most. And whilst that tends to be the smaller, more random read I/O traffic, actually that's not always the case. So Velocity uses a very lightweight storage filter driver to gather telemetry information. And this allows Velocity to learn useful things like, what is the main application in use on a machine? What type of files are being accessed and what type of storage I/O streams are being generated? And at what times of the day, the week, the month, the quarter? So it can be very intelligent about what the hot blocks of data are that need to be in the RAM cache, and more importantly, when. And it can also use that telemetry to figure out how best to size the storage I/O packets to give whatever the main application is the very best performance. And if the way you use that machine changes over time, well, Velocity can automatically adapt to those changes without you having to reconfigure or tweak any settings. Validating results is really easy. First of all, you could measure the amount of SQL transactions being done each day to see if they increase. Some customers see reports that they generate take less time to produce, or SQL imports take less time, batch jobs complete more quickly. Some customers have even done a simple stopwatch test to measure record retrieval times. However, Velocity itself comes with very transparent reporting that'll show you exactly how much storage I/O traffic it's able to eliminate from that disk storage layer. You can see what percentage of the reads and writes are being eliminated, and it'll show you how much storage time is being saved by the storage not having to process that eliminated I/O. Now, if you're using thin provisioned storage, Velocity can help you also reclaim space. If you're using, for example, thin provisioned VMDK files for your VMware VMs, it can automatically zero out free space for you so that you don't have to wait for hours for something like an sdelete pass to complete. If thin provisioning down at the storage layer, it can also send SCSI unmap commands down to the storage controller to notify it of blocks that are no longer needed. And if your VMs are provisioned with dynamically allocated RAM instead of a fixed amount of RAM, such that the hypervisor can borrow some back to reallocate to some other VM, it's important for best practice to make sure that you reserve enough RAM in your SQL VM's configuration for both SQL and Velocity. Otherwise, too much RAM in the VM could become driver locked by the hypervisor's ballooning driver, and that would mean basically that Velocity might not get enough RAM to cache with effectively. Now, these are just some of the case studies that you can access on our website at conducive.com. And I won't bore you by going through all of these because I'm just an engineer. I'm not a sales or marketing chap. But as an example, you've got Bell Mobility on the bottom left. They're a telecoms company in Canada, and they saw the Velocity software reduce the storage I/O traffic to their SAN storage by 61%, which is huge, 61% reduction. And this gave them SQL report queries that were 3 times faster, with no additional hardware being required. All they had to do was simply install the software, which, as I mentioned earlier, is completely non-disruptive. There are no SQL code changes required, no reboots required, and zero disruption to live running workloads. So, firstly, I hope this has been a useful session. I would encourage you to share what you've learned in this session with colleagues and see what they have to say about this. And I'm recording this session as well, so it'll be made available to everybody a little later on, in case you wanted to share the recording too. Really, the simplest and best way to test Velocity is just try it for yourself with your real-world workloads. And as I mentioned, everyone who's attending today will receive a full copy of the software from Conducive directly, worth about $525 US. I think in UK pounds, that's about £400. really make sure you follow the best practice tips that I went through for best results, or reach out to me for help, and I'd be very happy to help with. But the key thing to keep in mind is try and make sure that you leave at least 4 gigabytes of RAM free to cache with, to allow us a reasonable cache size. And of course, you're very welcome to share that dashboard report data with a conducive engineer to get additional analysis and get a written engineer's report. The email shown on the screen will get you directly connected with the lead engineer for each region. Even if you have any questions after the presentation, you're very welcome to reach out. The second email on the screen is one that will come through to me directly. So I'm the Senior Regional Solutions Engineer for EMEA, so that's SRSE EMEA at conducive.com. If you're in North America, then use the first one, SRSE 1 West. We'll be very happy to help you with any of this. So basically, if your organization could benefit from faster storage at a reasonable price using the storage hardware that you already own, I would urge you, just give it a try. You're not going to disrupt any live running workloads. You don't have to make any SQL code changes, and the whole download and installation really will take no more than a few minutes. Use the software to not only identify those servers that cause storage I/O issues, but fix those issues at the same time. So I hope that's been useful, and I am very grateful for you all for staying on. I'm just going to stop sharing my screen for a moment, and we'll see if there's any questions to go through. Okay, so Brett has sent me a question. He says, does it support more than Microsoft SQL? We are looking at running it on an Interbase server. So, Brett, great question, and thank you for that. If your Interbase server is using Windows as an operating system, then yes, it will work. If it's being hosted by some other type of OS, like Linux, for example, then no, you can't install Velocity on Linux. It is a Windows-only solution, and the current version will run on any Windows server, including Windows Server 2008, R2, and later, up to and including 2016. And we also have versions of this type of I/O reduction and caching software that you can run on client machines as well. Maybe you've got some power users that need more performance out of their workstation. Well, you can install it on Windows 7 and later as well, right up to and including Windows 10. So I hope that answers that. Let's see if we have any other questions. Baptiste says, is it compatible with Always On? Yes, it is. Basically, because what we're doing, sorry, excuse me just one moment. I just need to clear my throat. Good. Hopefully I hit mute in time. So is it compatible with Always On? Yes. What we're doing is at the Windows operating system layer, but what we're not doing is bypassing Windows in any way. So for example, it's still the standard Windows write driver generating a standard NTFS I/O packet and sending it on down to the storage. We're not replacing any part of Windows. So as long as Always On is compatible with the Windows OS, which of course it is, it will be compatible with our software. And Brett sent me another question. Is it limited to 64-bit versions, or will it run on 32-bit operating systems? The installer package actually comes with an installer for both 64-bit architectures and 32-bit or x86 architectures as well. So you're not limited to just 64-bit operating systems. It'll run on either. So I hope that answers that. And Shaquille says, since you said it supports any type of I/O reduction using Windows OS, how about Exchange Server to make faster connections? Great question. We have a lot of customers using it on Exchange Server when they're running Exchange on-prem. We have great results there. Also, other workloads like busy file servers, um, busy IIS servers. People use it to improve the performance of things like business information systems, SAP or SAP, IBM Cognos, document management systems, um, even things like Sage Payroll and Sage ERP systems. In fact, I actually wrote a case study in conjunction with one of our customers just recently on that. So it isn't just limited to SQL Server. It will work basically with any storage I/O intensive workload that you're running on Windows. So I hope that answers that. Let's see. I think that's all the questions so far. So I'll keep an eye on it, see if any others come through. But hopefully I've done a reasonable job of explaining this, which is why there's not too many questions. But even after the presentation, if you have any questions, you're very welcome to reach out to me directly. I have no problem with that at all. I'll be more than happy to help. There's another question just popped through from Luis. He says, may I install the given license on one server and move it to another server later? So, Luis, you're talking about the full free copy that everyone attending today is going to receive. And the answer to your question is yes. As long as you only use it on one machine at a time, it's up to you which machine you want to run it on. So you can install it on one SQL server and then uninstall it and then install it on another SQL server and then uninstall it and try it on your file server. Absolutely, no problem. But if you really want to do a proper proof of concept in your environment, again, reach out to me or to one of the other Conducive chaps, and we can provide you with 30-day trialware, which will run fully featured for, you guessed it, 30 days. But what that means is you can install it onto all of your machines at once. And now, from the point of view of the storage, it'll now be doing the least amount of work. That's really how you can see the full power of the software in your environment. Reduce as much of that storage traffic as you can across all of the machines that are sharing that same backend storage, and introduce that RAM cache to all of the Windows machines that you're running. You can get that trialware without obviously coming to me as well. Let me put the address for that in the chat box here. So it's conducive.com/try, and I've just spelled that wrong, so ignore that, forgive me about that. Conducive.com/try. There we go. If you put that into a browser, you'll see a little registration form, and from there you can get the fully featured trialware. And yeah, we'll be more than happy to answer any questions on that, help you install it if you need it, although, to be honest, it's a very simple sort of next finish type install. But maybe you've got hundreds of machines, in which case, again, we can provide you with the Velocity Management Console, which you can use then to push install the Velocity agent out across the network from one central place. And then you've got a single pane of glass, effectively, to control licensing, gather aggregated reporting, and all of that sort of good stuff as well. So if you want any assistance in setting that up, again, you're more than welcome to reach out to us. So I think that's it for all the questions. I can't see any others come through. So I really hope this has been a useful session, and I certainly look forward to speaking with some of you soon. Do feel free to reach out, and it just remains for me to say thank you very much for your time, and yeah, have a very good rest of the day. Take care all.